I am an engineering geologist, and engineering geology, for those who are not aware, is all about looking at how the built environment interacts with the ground. And so my specialty is in landslides and landslide management. And I've been doing landslide management in Yarra Ranges for the last 25 years and have sort of followed through the amendments to the planning scheme as we go. So I hope to leave you tonight with a good understanding of what the landslide issues are in Yarra Ranges and what council is doing or does to manage those issues, and what this planning scheme amendment is intended to do and the purpose of it. But before I start, just to acknowledge that we are meeting tonight on the lands of the Wurundjeri people of the Kulin Nation, and we pay our respects to their elders past, present and emerging. Now, I start off by just mentioning this term erosion management overlay, and it's got this word erosion in it, but under the Victorian planning scheme, erosion is used to refer to any land degradation process, which includes landslides. But when we're talking about this erosion management overlay and the Yarra Ranges, we are talking about landslides. We're not talking about erosion in the sense of gullies eroding out or material sort of getting washed off hillsides. We're talking about landslides, and the Yarra Ranges erosion management overlay is all about landslides. Now, one could argue it could be called a landslide management overlay, but that's the terminology. So just to make that clear. So what we'll go through, what landslide and debris flow hazards we have in Yarra Ranges, and I'll explain the difference between the two. How landslide hazards are managed in Yarra Ranges and how they're managed through the planning scheme. What are the updates we're proposing to the planning scheme? And then we'll finish off with just some practical tips and information that you can use around your own property to help manage landslide risks. And there'll be time for questions. So to start off, what is a landslide? And in a very general sense, a landslide is the movement of soil or rock down a slope under the action of gravity. And so things like rock falls or sort of mudslides or anything that involves earth moving down a slope under the action of gravity, we call a landslide. And there's lots of different types of landslides. I'll just put this diagram in to kind of illustrate some of the features and some of the terminology I might refer to. A landslide has what we call a zone of depletion and a zone of accumulation. And in simple terms, soil or rock comes out of the zone of depletion, it moves down the slope, and it is deposited in a zone of accumulation. So when we come and interact, our built environment interacts and we put things on a landslide affected area, we're concerned with movement up here, undermining or impacting property. We're concerned with, say, development down here that could be impacted by material that comes down the slope. So it's important that, and we do, seek to manage impact to property and to life from these landslide movements. And if you've lived up in the Yarra Ranges for any significant period of time, no doubt you've come across landslides. We've got one blocking the tourist road up at Sassafras at the moment. Every time we get a big rainstorm come through, there's usually landslides affecting roads, affecting properties. You would have come across landslides in Yarra Ranges if you've lived here for any significant period of time. But I'm going to split out a particular type of landslide, and that's what we call a debris flow. So a debris flow is a type of landslide, but it's one that involves mud. It involves fast-flowing fluid. You might hear the term a mud flow or a mudslide. So a landslide could be a block of ground that just moves sort of slowly and kind of stays intact, or it could be the ground becomes so wet that it's able to flow and it loses all strength and it flows down slope and infills gullies and can flow a long distance. This particular image you may have seen in the news back in January. There was a landslide down at Macrae in the Mornington Peninsula, and that was a debris flow, and the soil detached from up near the top of this slope from around that area. It flowed down, piled up against the back of this house, and over successive sort of debris flow events, enough soil was piled up against that house to knock it down. And subsequently, they've evacuated that area, and I've been involved in the parliamentary inquiry into that. So this is the sort of thing that we are seeking to prevent by having planning controls around landslide and, in this case, debris flow. Now, one of the amendments being made or being proposed now is to split out different controls for debris flow versus landslide. Now, we'll talk about both tonight, but this particular session is weighted a bit more towards people in what will be called EMO2, which is to do with debris flow. So these are these fluid type landslides that can travel long distance, and they can be quite destructive because they're moving with velocity. They can take out things ahead of them very, very easily, and they present more of a risk to life than, say, a landslide where the ground moves as an intact block. That's a risk to property. Debris flows present a greater risk to life. Now, the influences on where these occur is the type of rock or soil that we have. Now, if we look up in the Yarra Ranges, we don't have, say, Mount Dandenong area, in fact, anywhere in Yarra Ranges, we don't have very, very steep slopes. We don't have gorges or ravines, or like we might see if we went out to the west of Melbourne, out to Werribee Gorge. We went up to the north of Melbourne to Plenty. We have slopes that are actually relatively shallow. You won't find a natural slope up around sort of the Dandenong area, or Mount Dandenong area, more than kind of 2 horizontal to 1 vertical. And that's to do with the type of rock or soil that the mountain is comprised of. It just can't stand over long term. It can't stand steeper than about 2 horizontal to 1 vertical. And when we go and, say, put roads in and we cut it steeper than that, it can stand there for a while. It can stand there for decades. But eventually it comes down, and that's why every time we have a big rainfall, we find soil out on the road, because these slopes are cut steeper than the kind of what we call the angle of repose, the angle that over the long term that soil stands at. So the geology is an influence on landslides in Yarra Ranges, as is the slope angle, and in a general sense, the steeper the slope, the more likely a landslide. But the trigger for landslides is how much water gets into the soil. A slope can sit there perfectly fine with no impact and nothing happens, and it can sit there for decades until the soils become wet, they become saturated, and then that can trigger a landslide. So we're very concerned with things like drainage and where water is directed, and a previous history of landslides. So development can influence all these things. We can influence the terrain by doing earthworks. We can influence the slope angle by doing that. And in a way, we can influence the geology by putting fill in places. We can influence it through water in the soil. So the erosion management overlays that are currently existing and that are proposed are all about controlling development so that we don't introduce landslide hazard and landslide risk, that we don't make slopes more susceptible to landslide. In a general sense, the more impact we have on the natural landscape, the more we can influence the potential for landslides. The landscape has evolved over thousands of years. Drainage courses have established, and we've got to a reasonably stable landscape. But it's when we come along and we interrupt that by putting roads in, by altering where water flows, by altering how steep things are. Humans have come along, and we have, we've made the Dandenongs more susceptible to landslide because we've altered the natural landscape. And so this is all about, as we continue to develop, that we don't increase the susceptibility, that development is sensitive to landslide hazards. There's lots of good reasons we don't want to be impacting life or property with landslides. Just a slide in here, just to sort of note, you don't always need to be on a steep slope to be potentially impacted by landslides. I've just got this little sort of diagram here. Some of the slides we have are very, very big, hectares in size. Some of the ones up around Sylvan area are some of the biggest in Australia. And a house or a block would occupy a very small part of that very large landslide. And you get something like this, we tend to want to build our houses on the flat areas, which are these sort of flat terraces in amongst a larger landslide feature. So that's one of the reasons it might be on a flat area. It might be that our house is at the bottom of a hillside and a landslide can travel down the hillside, and so the house is in the zone of accumulation I showed before, otherwise flat, that can be impacted from what comes up above. Or our landscape's been modified through earthworks. What's naturally a slope has been modified through earthworks. So there's reasons why we might be on a flatter piece of ground, but that's still in a landslide or potentially impacted by a landslide. So just to give a bit of history, I've selected a few. There's been hundreds and hundreds of landslides across Yarra Ranges that we've got recorded, but I'm just going to pick out some of the more notable ones to give you a flavour of why do we need to have planning controls? What's happened in the past that's gives us this indication of landslide hazard. Probably the most famous landslide in Yarra Ranges goes back a little while, occurred in 1891. It's called the Montrose debris flow. So on the slopes up above Montrose, there was a huge rainstorm, and in 12th of July 1891, a big landslide came off the side of the mountain. And you can see in this image here, this is Kalorama up here. This is north. You've got the northwest facing slopes of Mount Dandenong, and Montrose is down the bottom here. And you can see these, we call scarps, that kind of look like holes in the side of the hill. They are debris flows. This is where rock and soil has detached from the hillside and has flowed down following these gullies. And in fact, the 1891 landslide went about 1.5 kilometres, ended all the way up down here. If you stand down there, you can see, to a trained eye, you can see the debris that came from that landslide. You can't even see the mountain from the cave. It's sort of obscured. You would have no idea where it came from. It's only when we zoom out and look at models like this, we can see where it came from. So the 1891 landslide originated there, and you can walk in, and it's a bit of a tough trek, but you can find that site. At the time, it destroyed 2 houses. It buried 2 people, but they were rescued. Killed a couple of horses in the stable, but otherwise, at that time, it was an open rural area. And so you can see this is an image from 1904, which is taken from roughly where the Montrose shops are now, looking up down. This is where the footy ground and the playground is, looking up towards Mount Dandenong up here. And the debris flow kind of, just see the scar when you zoom in on this, sort of flowed down through here. And that shot on the right is the hole in the side of a hill where this material came out of. It became a bit of a tourist attraction in the 1890s to go and visit the site of the Great Landslip at Mirralbark. And there's a very, very interesting write-up in the paper at the time, which sort of describes it all in this really flowery Victorian language, but gives us some great information about what happened. And I still have no idea how this photo was taken because I didn't have drones in the 1890s. Maybe someone climbed up a tree or something. But you can just get a sense of the scale of this landslide. And I said you can still go today, and it's a bit more overgrown than that now, but you can go and see that scar. But you can go back here. This is one of many that are on the hillside. There's only one that's happened in European recorded history, but there are many that have happened. And when this was first studied in the 1990s, they excavated pits down the bottom of the hill and could map the layers, track the layers of debris, and sort of work out how frequently these things happen. And it's something like about a 1 in a 200-year event that we get these large debris flows off the side of the mountain. But of course, with climate change, how frequently we get these extreme rainfall events, who knows? It might change. So that's one, and that's a natural process, those debris flows. It's like an earthquake or a volcano or any other geological process. They just happen. We can't prevent them. Debris flows will happen when we get the right rainfall event. But this is one that was a near miss. It's probably the one we've had closest to killing somebody in Yarra Ranges, which happened in the early 90s, 93. And this is one that was preventable. This is fill that somebody had placed to form a level backyard. You can see there's a stormwater pipe draining into that fill. The fill got wet and the fill slid down the hill and it impacted the house next door. Came down over the wall here. You can see on the side of the garage how high it came up, and there was somebody in the backyard. Now, if you were in the backyard there and that came down on top of you, you wouldn't survive that. Uh, but there was someone in the backyard, and they were not quite in the path that hit, and they got out of the way. Apparently, it was a teenager sneaking away from parents having a cigarette in the backyard. But that would have been fatality if that person was in the wrong spot. But that was preventable because that was poor earthworks and poor drainage, and that is exactly the sort of thing that the erosion management overlay provisions are there to try and prevent. This is one that, if you've lived up here a little while, you might remember. This was January 2024 in Tremont. And we had early January, we had a very wet period. I remember getting the call out to the SES was on site. There'd been a landslide that had come down near the tourist road, and it destroyed a house. And you can't quite see it in that image, but there's a house that's been flattened under that. So the house was completely buried. And at the time of the initial response, nobody knew if that house had anybody inside it. It turned out, fortunately, that it wasn't occupied, but it could have been. There was no particular reason why it wasn't occupied. And that house was flattened. So it's real. We've got very recent examples of very serious landslides up in the Yarra Ranges. This one was caused by a very steep slope, and we had stormwater. We had poor stormwater drainage directed onto this slope, which wetted up and caused this debris flow. It flowed all the way down the hill and impacted that house. This is another very famous one, which was studied, goes right back to the 80s. And this is in Chirnside Park, Plants Hill. You sort of recognise the water tower on top of the hill in Chirnside Park. So this is a primary school, and to make room for an oval, they've excavated into the side of the hill. And when they excavated into the side of the hill, this big landslide occurred. Melbourne Water had just built this big tank up the top, and they were incredibly concerned, and rightfully so, that this landslide would get bigger. It could potentially undermine that tank. And if you had a huge water tank let go above a primary school, that doesn't really bear thinking about. So they acted very, very quickly. There's a really interesting records, but they dug down holes down here, and they could see evidence for landslide. They immediately drained the tank. That tank's no longer there. The one that's currently there was rebuilt further back. But that could have been quite a serious one, a near miss. They had some smaller slides. This one impacted the building, but didn't have enough energy in it to impact knock the building over. But this was excavation in a landslide-prone area, disturbance of the natural landscape that triggered what could have been a very serious landslide. Blackwood Avenue in Warburton. This one my boss worked on, and he's now retired, but he said that one of the toughest decisions he had to make was the 4 houses that were in this area on this landslide when it moved. He was the one who had to make the decision as to whether to permanently evacuate those people from their homes, which he did, and they were evacuated. This landslide moved several times. It moved in the 70s, and in the early 90s, it was moving down towards the Yarra. So this is on the slopes just above Warburton, to the north of Warburton. And this landslide was moving down in response to water getting into it. It's a natural landslide. This is not one that was triggered by any sort of development. It was just natural water in the slope. And it was moving. You can see the road offset there. The road is all offsetting and moving. And they didn't know whether this landslide was going to speed up or stop or slow down, so they evacuated it. And it turned out that it did slow down, and you can now still walk along that road. You can see all the damage the landslide caused, and you can see the foundations of the old houses. But this is natural, and again, there's no particular reason why that won't move again in the future if the groundwater conditions are right. And a more recent one, in Monbulk Seville Road. This image down the bottom right is what's called a LiDAR image, and it shows up the terrain, and you can see there's a prominent sort of change in the slope here, and this ground is actually quite flat. It's about 5 degrees, which is relatively flat. There's a dam here, but what's happened here, water got into the soil, and the deep red soils that we sort of know of around Monbulk, Seville, Sylvan area, which are great for growing bulbs and flowers and tulips in, but are very prone to movement when they get wet. And in this case, it may have been the combination of wet weather and the combination of a dam and got the soil wet and is able to move at a very, very shallow angle. Monbulk Seville Road was closed for a while, and this house down here moved. It got sort of pushed up and all warped inside. But this type of landslide, very slow moving. It's not a debris flow. It's a slow moving block of soil. It's not going to be the type of thing that would present any risk to life, but it's enough to cause damage and disruption, which is what happened here. So that's just some examples of some of the sort of more prominent landslides that we've had. And this has been something that Yarra Ranges has been prone to for ever since European settlement, and it's really only since about the 90s we've had planning controls in place for them. So the planning control we have is called the Erosion Management Overlay, right? And the mapping, and this amendment's all about changing the mapping. The mapping indicates to us areas in Yarra Ranges that are susceptible to landslide. And that doesn't necessarily mean landslides have happened there. It means they are susceptible to it. So if we had inappropriate development, like the ones I showed there, that inappropriate development, maybe poor drainage, maybe poor earthworks, maybe indiscriminate vegetation clearance, could give us the conditions to cause a landslide. And so that's why we have the erosion management overlay in place, is to ensure that we have appropriate development, that we're not going to undertake development that could lead to causing landslides. It's going to present a risk to life and property. So it's areas where they could occur, but also covers areas where we know they have occurred in the past. And so essentially that's what the mapping of the erosion management overlay is, areas where landslides and debris flows are known to have occurred in the past, or where we have terrain that is very similar to where they've occurred in the past. And that's the mapping of the erosion management overlay. And then we put planning controls in place in those areas to make sure we don't make that land more susceptible to landslide or do anything that could trigger landslide. The sort of things that trigger landslides in Yarra Ranges is water getting into the ground. That could be leaking surfaces, that could be poorly directed stormwater. Now, it could be earthquakes, but we've never had an earthquake triggered landslide in Yarra Ranges. We have very close to, we had one up at Woods Point. But that can trigger landslide. Whilst we're able to work out where landslides can occur, and that's informed by where we know they've occurred in the past and from our geological science, we cannot predict when. So it's like most geological hazards, like earthquakes, for example. We know where earthquakes are likely to occur. We cannot predict when they occur. And so that's what our mapping shows, where they could occur. So the process that we go through to identify landslide susceptible areas, we put together what's called a landslide inventory, gather as much information as we can about where landslides have occurred in the past. And that information comes from historical records, but it also comes from analysing the terrain, what we call the geomorphology. So we have geomorphologists who are specialists in the terrain to identify evidence for landslides in the past, because geologically we only have a very, very short recent history to go off. We haven't got records that go prior to European settlement, but we have the footprint in the landscape of past landslides, and we can go out and a trained geomorphologist can identify areas that have been affected by landslide, going back before we have records. Once we get the inventory together, that data is analysed, and we look at it and we say, on what type of geology have we seen landslides in the past? At what slope angles have we seen landslides in the past? And then we develop criteria for inclusion in the EMO based on that. So the criteria are around what's the underlying geology and what is the slope angle, and has a landslide occurred here in the past? And those criteria are no different to what's currently there now. So this amendment, whilst it changes the mapping and the areas affected, doesn't actually change the criteria for inclusion in the MO, which is based on slope angle geology and whether there's been a landslide there in the past. So we identify for debris flow. What we do for debris flow is look at gullies downslope of where landslides could occur and where debris might be channeled. And we map up those, and we've got techniques for working out how far along the gully debris might go. And we map that up, and that's what these are showing here. So a bit on the history of this. There's been some quite serious landslides through the 1980s, and some houses got destroyed in those landslides in the 1980s. And the Shire of Lilydale, as it was then, put what was actually some of the first landslide controls in Australia were put in place in the early 1990s. In 92, because the Montrose debris flow was known about, very comprehensive study with some real top experts in landslide management did a study in Montrose in 92 to recognise all the areas there that could be affected by debris flow if there were to be another one in the future. 99, the various councils merged, and then the Shire of Yarra Ranges Erosion Management Overlay was sort of developed and was put in place eventually in 2001 to map all the areas in the Yarra Ranges that could be landslide susceptible. Now, in 2007, we got some national guidelines for landslide risk management. Those who are old enough might remember the Thredbo landslide in 1997, which killed 16 people. Sort of one person survived that, who's now actually the CEO of the Thredbo Resort. But out of that tragedy, there was a whole lot of work done around how we better manage landslide hazards in Australia. There was coronial inquiries, and the recommendations there were, hey, we need to do this better. So there was national guidelines developed in 2007, and those national guidelines are now what we refer to, and they're used all over the country, but they set out the guidelines for how we do this work. How do we identify landslide susceptible areas? How do we manage the risk of landslides? That's all to these national guidelines, which are called the Australian Geomechanics Society Landslide Risk Management Guidelines. There's been various amendments to the mapping in Yarra Ranges, which have generally related to things like land use change. So, example, Melbourne Water gave some property back for residential zoning a few years ago, and that had to be included and the like. And then just last year, the schedule, which sets out the planning controls, that was updated just last year. But the mapping has never been significantly revised. Now, this map here, which is a 1960s Melbourne Metropolitan Board of Works map, which is, you can sort of hardly read the thing. These contour lines on those maps are based on 1960s photogrammetry, looking at air photos. And the way the mapping was done, which is in the late 90s, people would sit down in front of the hard copy map using scale rules and work out the slope angles and go around working that out everywhere. And then that would be how the criteria on geology and slope angle would be transferred to the map. So it was all very, very manual. Since the early 90s, the technology as to how we can do this has come a long way. And that's really a primary driver for why we're updating the mapping or proposing to update the mapping. So what we've recently just done, reviewed the landslide inventory. So reviewed this knowledge of all the landslides in Yarra Ranges. So revisit the history, but re-look into the landscape and identify landslides and build the landslide inventory. Gone and checked, are the criteria for inclusion still relevant with this new knowledge? And we found, yes, they are. So the criteria for inclusion have not changed. But also to separate out debris flow from landslide, given they're quite different in terms of the consequence they can have. And so now there's will be separate schedules for each of them. Some examples of how this looks. These images are from LiDAR. LiDAR is a method of getting very, very detailed digital terrain models, so we can get a far, far more precise form for the landscape than we can using those old hard copy maps. And for example here, this red line was something that was identified as a landslide back in the 90s based on historical evidence. And with the LiDAR, it's the same site. You can see very clearly, actually, there's two landslides. There's one there, one there and one there. It shows up quite well. You can see the difference in the texture. So to a trained eye, we can pick out the landslides far, far more easily than you could in the past. Very, very clear difference through there. That's up in Kalorama, that one. Here's one in Sylvan. Very clear. You can see this very smooth terrain up here, and the landslides here just pop. This is all lands that sort of move down slowly over time, and as it moves, it tilts and it moves and it gets all this hummocky ground through there. So our ability to identify where landslides have occurred in the past is orders of magnitude better with sort of new technology now. I first started using LiDAR around 2007, I think, when it sort of first was a new thing. Wasn't really in common use in sort of the landslide, sort of amongst landslide professionals till about 2011. And it's just getting better and better. The resolution we can get now is amazing. So it's really a game changer for identifying landslides and doing landslide mapping. And so with such improved technology, the need to go back and revisit the mapping in Yarra Ranges. That's just a far field of the whole of Yarra Ranges, showing the landslides that's been identified now using the LiDAR information. And you can see, not surprisingly, the steep slopes to the north of the Warburton Valley and a few to the south of the Warburton Valley. The slopes over in the Dandenong Ranges, and then we get a lot around this area through Monbulk Sylvan area. Not too many up north. And the reason for there's not too many up north, this is Yarra Glen sort of area. Different geology up there, not as prone to landslides to the geology that now Dandenong and these areas are under. So not only can we identify landslides better from the LiDAR, we can apply the criteria much more accurately. So what this map is showing is slope angle. It takes the digital terrain image and we can ask it to calculate slope angle. So there's no scale rules on hard copy maps anymore. We can be far more accurate with how the criteria are applied to indicate landslide susceptible areas, and that's been done. And this image here shows what's changed. So blue is areas that removed. There's areas that we found didn't need to be in the EMO because based on the new mapping, they were a bit conservative with their scale rules. Yellow is areas that are now in that weren't previously identified, and I suspect it's because the 60s maps just weren't as accurate over that area, and they didn't recognise weren't able to map the slope angles as well over there. Green areas is no change, and most of the properties with this amendment there is no change to. And red are debris flow areas, so they occur around the Montrose area, and they occur on these slopes just to the south of the Warburton Valley, and there's one over in the basin actually that we've mapped up as debris flows. So that's the change. The changes that are being proposed in this amendment essentially boil down to we have far better technology for identifying landslides and mapping landslide susceptible areas than we did in the 90s, and we need to update. So then there are planning controls. Once we've identified a landslide susceptible area, we need to make sure that the development is undertaken appropriately in those areas, that we don't, works aren't done that could lead to instability, works aren't done that can create a risk to the neighbour, or somebody upslope of you doesn't go and put fill in like that one at Charles Road. So we have planning controls. Now the planning controls are set out in the amendment that was put in last year in 2024, and they're not really changing. What's changing here is the areas that we've identified as being impacted. But the planning controls are all about limiting earthworks, limiting the potential for water to infiltrate to the soil. So if we are doing earthworks, that they are as minimal as they can be, that if we have to do earthworks, appropriate retaining walls, appropriate retention is in place to ensure stability. Where there's drainage, that drainage is properly controlled. We're not allowing water to indiscriminately get into the soil. If we have tanks or pools or dams or ponds, or we're ponding water, that's appropriately lined, that we're not allowing water over decades to leak into the ground and wet it up and cause landslide. It's important to involve geotechnical specialists, and the provisions allow for that. If we've got new development, we should be getting geotechnical advice. And that advice is looking specifically at the development we are proposing to say, well, what should you do as part of this development to ensure that we are managing our landslide risk? We want to retain vegetation. And there's a little bit of a conflict here with bushfire regulations where we want to clear vegetation around the house. For slope stability and landslide, more vegetation is better. Vegetation reduces the likelihood of landslide. So we retain it where possible. But in Yarra Ranges, I can tell you that the bushfire risk trumps the landslide risk. Bushfire is a much greater risk to life and property. And so if there's a conflict between what you would do to manage bushfire versus what you would do to manage landslide, the bushfire controls take precedence. There are very few areas where it's not appropriate to develop at all, but there are some. And they are generally in gullies downslope of debris flows. So the Montrose example, if it were to be another landslide off Mount Dandenong, that debris is going to flow down the natural gullies, and anything in those gullies is in the path. So, yeah, we really don't want development in gullies. And most of the time, you're not going to go and put a building in the middle of what's essentially a creek. But it happens. So the controls around debris flows are about avoiding development in gullies where if debris were to come down, it would concentrate and flow. So the Schedule 1, which is what's in place now, it sets out what type of development would require a planning permit. And it's not all development. It's really only development that has the potential to make a site more susceptible to landslide or increase landslide risk. So it's things that involve earthworks, involve vegetation clearance, involve changes to drainage or discharge of water on the site, or that involve putting habitable space and buildings potentially in the path of landslide or debris flow. And so the schedule sets out what type of development needs a planning permit, and then includes in there what measures need to be taken to ensure the landslide risk is managed for that development. It requires a geotechnical engineer to be engaged, and their job is to come to the site, look specifically at the development that's being proposed, and give advice on how to manage the landslide risk for that development. That's set out in Schedule 1. The new EMO 2, which relates to debris flow, and it only covers those very localised areas in Montrose, Warburton, and one in the basin. It's been separated out because with debris flows, it might originate well above somebody's property. They come from right up the top of Mount Dandenong, say, and flow right down through Montrose, and there's very little, if anything, that can be done to prevent them particularly on a site at the bottom of the hill. So those controls are all around and all based around avoiding development in gullies. So we're not putting development in the path of where these could flow. So the strategy is avoiding development in gullies, and a planning permit in the EMO 2 areas will generally come into place if we're doing anything that encroaches upon a gully that could see debris come down in the future. So those new schedules I think they're on exhibition for you to review. So the type of planning controls that a geotechnical engineer might recommend, they probably recommend avoiding vegetation removal. They probably recommend minimising earthworks. And if we do need earthworks, which we generally do if we're developing on a hillside, that they are minimised and that they are properly supported through retaining walls. There's appropriate drainage to prevent those earthworks becoming wet, becoming unstable. That's what a control that should be recommended. That drainage is controlled. Stormwater is directed to a legal point of discharge. We would avoid things like water-bearing surfaces in filled ground that might move and break and leak water into the ground. If we have water-holding structures, we'd ensure they've got what's called under drainage. So if they were to leak, that water is picked up in a drain and taken to the surface, not allowed to leak into the soil for decades. So that's the kind of planning controls that are in place. On-site wastewater or sewer disposal, back in the old days, we would have realm drains or absorption trenches that concentrate wastewater into the ground. In a landslide area, the approach is to disperse that over as large an area as possible. We're trying to avoid as much as we can water concentrating in the soil where it doesn't naturally concentrate. That's where we can lead to landslides. So they're the sort of planting controls you would expect if you're in an area subject to the erosion management overlay. So the sort of development that triggers a permit, new buildings and extensions more than 20 square metres. So this is not intended to pick up your little garden shed. It's intended to pick up more substantial development. So 20 square metres in area. Our buildings of more than 40 square metres, which is relatively large. Water-bearing things more than 5,000 litres, so little water tanks for the garden. That's, we're not going to, they're not got the potential to put enough water into the ground, but anything larger, like pools, they do. So they are subject to a planning permit. Earthworks or retaining walls more than 1 metre. So that something 1 metre has high has the potential to trigger instability. For example, if this were to be on a construction site, WorkSafe Victoria wouldn't allow anything more than 1.2 metres for somebody to get into. So in a residential setting, we need to be more conservative for that. So if we're cutting earthworks more than 1 metre, it needs to be assessed, and it probably needs a retaining wall to hold it up. So it's not intended to pick up landscaping, in which you generally wouldn't be cutting excavations more than 1 metre. So it's not intended to pick up that. It's picking up the things that can actually present a hazard. And vegetation removal. If we remove substantial vegetation, that can allow the soil to get wetter. That can lead to landslide. So for debris flow, it's all about avoiding the gullies. These are some shots of a landslide response I worked on at Wilson's Prom. And if you've been down there, you would have seen this. 2011. Some very, very serious debris flows in Wilson's Prom National Park. It isolated people at Tidal River for a while, actually. They couldn't get out. The road was taken out. It shut a lot of the tracks for a long time. But that's a shot. That used to be called Ferny Glade. And if you know Wilson's Prom, it's on the track to Sealers Cove. And it's now Rocky Ravine. But it just showed the power these debris flows had. This is landslides at the top of the hill, and they just move down and they carve out a gully. They get bigger as they go. They entrain material. And I put that up because it's always, after having the experience of working down on that, you think if the rainfall event that triggered this, which was extreme rainfall event, if that had have landed on Mount Dandenong, we've got similar geology to Wilson's Prom. This is the sort of thing we could have had, and it's potentially catastrophic. So it's a real event. It's a real phenomenon, and we do need to do whatever we can to manage and reduce the risk of these debris flows. So just to finish off, a couple of things that we can do just as landowners to help manage our risk of landslide. So minimising earthworks is a big one. Retaining the natural landscape as far as we can. Retaining vegetation. Maintaining retaining walls. This is an example here of a retaining wall that wasn't well maintained. Landslide occurred behind it, affected the neighbour. So, we want to make sure people maintain their landslide mitigations. Good to have it, but if it doesn't not maintained, then it creates a risk down the track. And do whatever we can to prevent water infiltration into the grounds. That means clearing out our drains, ensuring water is not indiscriminately going into the ground. It's directed to a legal point of discharge. If there are drainage problems on the street and water is not staying in the stormwater system, one of the common things I see when we're called out to look at landslides is water's been flowing down the road, the drain's blocked up, the water spills out over the drain, flows over to the fill side of the road, soaks in and causes a landslide. So if we see that type of thing, let's report it and try to get that addressed. That shot there is Montrose last year. We had a mini debris flow that came down the creek. It wasn't a huge one, not the ones I showed before, but it was enough to get down here and block up the drain, and then all the water couldn't get down the drain. It flowed over the road and it caused a landslide on this side of the road. So that was, that's just very, very small debris flow. Large ones can be far worse. So just a shot of what's good hillside practice, good development practice. Houses up on stumps are better than houses on slabs, because if we put a house on a slab, we have to excavate into the hill and we disturb the landscape and we make the site steeper. Better if we can avoid that where possible. Same with things like tanks. Avoid earthworks as far as we can and try to preserve the natural landscape. Control drainage. If we have water-bearing structures, put drains under them. Stay out of natural drainage courses to avoid debris flow, but also not to interrupt the natural drainage. If we must do earthworks, ensure that excavated material is not just left indiscriminately on the site where it can get wet and slide, but it's removed from the site and the earthworks are properly maintained. And then keep it in good nick. We have to maintain our drains, we have to maintain our retaining walls, and we have to, landslide risk management is an ongoing thing. So that's what I've got. I hope that provides some information as to what the landslide risks are and what this amendment's all about. And I think we've got some time for questions.
Thanks so much, Darren. That was really informative. We have had a couple of questions while you've been talking. I've answered a couple parts of it, but one of the questions is, have physical core samples of the geology or the ground been undertaken? And if you can explain a bit more about that.
Yeah, so what we do when we map this up is we're looking at landscape scale. Right? So we go back to these LiDAR images. This is a Linda. Right? We're looking at landscape scale to map up the landslides, and we're identifying landslide susceptible areas. The way the process then works is if somebody proposes a development in a particular area, well, you need to get geotechnical advice anyway, just for foundation reasons and building net reasons. But as part of that geotechnical advice, that is when they would come out, and that is when they would do boreholes, and those boreholes would be specific to the proposed development. The borehole should be located on the site, ideally where the foundations are going or where we've identified a slope stability hazard or we've got a retaining wall be constructed. And so the boreholes are done for a specific purpose for a specific development. And then the geotechnical engineer would use that information to help advise on appropriate landslide measures for that development. So whilst, yes, there are boreholes around, and yes, we look at them, and yes, it helps inform it, it's not a case of in developing susceptibility mapping that you go and pepper the whole shire with boreholes. That comes into the next stage when we're looking at a specific development.
Thank you. Another question was around the landslide inventory and how that's used. Just a bit more information on that.
Yeah, so the process is we map up all the landslides we have, and as part of developing the inventory, it's a database. And so it says, well, here we've got this landslide. Now, what are all the attributes of the ground associated with that landslide? What geology is it on? What happened when it occurred? How far did the debris run out? Was it in soil? Was it in rock? What rainfall event might have triggered it? So all of that information is in the database. And it's then a process of going through the database to pick out the trends. If I have, say, a geological unit, the older volcanics, I can filter out all of the landslides in the older volcanics, and I can say, well, what slope angle do I see these landslides occur above, and what do I see occurring below? And so then we say, okay, we see it above this angle, so therefore that will be the angle we use as our susceptible level. And then I'll look at what triggered it. What sort of rainfall event would trigger this? Oh, well, it seems like it's something like a 1 in a 50 or 1 in a 100 year rainfall event. Well, okay, that could happen, within the lifespan of development. So then therefore I will designate that as susceptible. So and these days now AI gets used a lot for this type of thing as well, as we can run all the landslide database through AI, and it can pick out, well, this is the criteria, this is what makes this land susceptible. So that's how the inventory, that's the value of the inventory. That gives us the information that we need to work out what parts of the landscape here could be susceptible to landslides, learning from what's happened in the past. So that's the value of the inventory. Now, that inventory, there's currently an inventory which is made available to geotechnical practitioners who work in Yarra Ranges. So if they're assessing a particular site, they have access to that inventory. They can see what landslides are known to have occurred around that area, and they put that in their reports. That inventory, with this work, will expand. So it is made available to geotechnical practitioners to inform their work. That's how we use it. It's a very important and necessary part of developing a landslide susceptibility map is the landslide inventory.
Thank you. And the final question, it's more about the risk categories that did apply around about 2005. Question, were categorised as M1. Just wondering if you can explain a bit more what M1 means.
I can. Oh, I've got it. Where's that old map? There we go. So you might have, if you got good eyes, have identified on here M1, M2, M1, M1, H. So the original classification that was done in the 90s, in fact, this was done shy of Liddell. The M classifications were done in 1991. And they had 3 levels, high, medium, and low. So anything low was not included in the EMO. Anything high was. Now, high was classified as anything that had been affected by a landslide in the past or was steeper than 2 to 1, like very steep ground was put in as high. The M classes was kind of everything in between that hadn't been affected by a landslide, but also wasn't low enough to not be included. And the 1s and the 2s are different geology types. So M2 was the rhyodacite, which are the slopes around Mount Dandenong. M1 was the siltstones, which is the slopes up near Yarra Glen. And in the end, the M1s didn't even get into the EMO when it was put in 1999, and all the M2s did. So that's what they were. Now, there were problems with the H M2 system. And one of them was that when the sites that were classified as H, as high, they got to this sort of point where they couldn't really be developed. It wasn't a geotechnical engineers would be going out there, this is high, you can't do anything with it. And it wasn't always appropriate. Just because a site's been affected by a landslide does not mean there's no means of developing it. So those classifications got taken out in about 2009. And the decision at that time was the EMO is either you're in or you're out. And then we rely on the geotechnical engineer looking at your specific development and advising whether the risk is acceptable. So that's the reason the H&M2s got taken out. It was too onerous to have that. And now it's just you're in or you're out, subject to site-specific assessment. But they still get referred to, even though it's been 16 years since they got taken out. I still hear people still mention them.
Yes, definitely. A couple more questions that popped up while you've been talking. The first one, it's about LiDAR imaging on the north side of Jellicoe Avenue in Moldenbulk, and whether it's possible to see that. Now, I know you do have access to all of that LiDAR data mapping. I'm just not sure if we're going to be able to bring that up tonight, but we can take that one on notice if necessary.
Yeah, only to say that there is LiDAR coverage, and that LiDAR coverage is integral to what we've done. I may not be able to actually have it on the computer here, but I might not be able to bring it up quick enough, I don't think.
All right, we'll get back to the resident about that one. And then another question, which I think probably a lot of people will be interested in, if you do have other overlays such as bushfire, for example, and something happens like a bushfire causes total loss to your property and your house is in a debris flow path, will there be any restrictions on rebuilding? That's the first part of the question, and then I can probably answer the second part.
It's a really good question, actually. I'm glad you asked that. So back in 2015, when they had the bushfires down at Wye River, down on the Great Ocean Road, and the fire went through there, and 6 months later, landslides everywhere. Why? Because retaining walls that had made of timber had burnt away, vegetation had burnt away. There was then a wet winter, and that water, more water getting in the soil, was able to trigger the landslide. So it is an important point, this relationship between bushfire and landslide. And a lot of research, actually Melbourne Uni does a lot of research on this exact issue. So what it means for development in Yarra Ranges is things like if we're building retaining walls, for example, and we're in a bushfire prone area, don't make them out of timber. make them out of concrete. If they do burn down, you don't want to have them burn down and then create a slope instability hazard. But when your geotechnical engineer if they go in to assess for development, one of the things they should be considering doing their risk assessment is to say, well, what if we lost all the vegetation up here in a bushfire? What would that mean for landslide susceptibility through here? So it is something that should be considered by the geotechnical engineer, and it is something that should be considered when we're developing landslide risk mitigation measures. And I did manage to find the Montrose LiDAR. That's a slope angle map. I'll see if I can turn off the slope angle. That's how we filter out to work out the slope angle. That's the what's called the hillshade. And I've got the sun shining the wrong way, but yeah, you can start picking out some landslides in the landscape. But in Montrose, it might be a bit too washed out. Oh yeah. And so we can see here, these are the old 1891 sort of debris flow areas up along the hillside there. And you can very clearly pick out the gullies, where this is going to potentially come down. Turn that on. Yeah, so these are all the mapping around the landslide gullies. And the way it's done is, we have geomorphologists and geologists who sit down with these images and map out the gullies and map out the tracks for the debris flows. In a lot of these areas, the work they did in 1992 still stands. We didn't actually modify Montrose much at all, really. It's the same mapping that was there, done in 1992, still held, and it was all done at the time in the 90s by hand of people out on the ground. So we map this out by hand, and then we go out and we ground truth it, check that what we've mapped off, the LiDAR is appropriate. But yeah, that's the Montrose LiDAR through there. You can see this very clear gully through there would be a potential pathway. If you had a landslide up in this catchment up here, you can see them. You can see all the landslides on the side of that gully there. That debris flows into this gully, and down there, that would be a debris flow risk. These gullies through here, landslides up here into that catchment, landslides there into that catchment, and debris flowing down those. So the planning controls around here are all centred around the gullies and avoidance of development in those gullies.
Right. Thank you. While you've got that LiDAR imaging up, I'm not sure if you can get Browns Road in Montrose on...
yeah, that's Browns Road.
Oh, we're there. Excellent.
That is Browns Road there, yep.
Yeah, we just had one of our participants just wanting to have a look at that. I did ask if,
Zoom in a little bit on it.
Maybe zoom. Yeah, it's hard. I know the roads aren't labelled.
Yeah, but that if you can see the hand there, that's Browns Road.
Yep.
Running through there. I think that's that's Old Coach Road, and that's Browns Road through there. So there's a very prominent gully running through there, which would be under debris flow, and a very prominent gully through there that would be under debris flow management. And you can see very clearly to a geomorphologist seeing that, you can see very clearly that debris has flowed down here in the past, has the potential to flow down there in the future.
And the second part of the rebuilding question was more about is council planning to buy back blocks that they consider to be unsuitable? So in Victoria, there isn't any ability to buy back blocks. It was a question looked at with bushfire some years ago, around about 2009 when the bushfires happened. State government doesn't support bush buyback, and council obviously just follows suit. For the most part, as Darren explained, you can build, but you just avoid the gully areas as much as possible. So I hope that answers that one. We don't have any other questions, so I think just to wrap up, I just want to cover next steps. So at the moment, obviously, the amendment is out for public consultation, open till 3rd of October. You can contact us if you want some further information. We have the mapping tool available on our webpage where you just type in your address and then it shows you how the EMO affects your property. And if you want to make a submission because you think there needs to be a change or you have concerns, you can do that. The process for planning scheme amendments is that we will then consider all submissions and review them, and they get reported back to council later this year. For submissions that we're unable to resolve, they get sent to an independent planning panel appointed by the Minister for Planning, and the panel will advise us of hearing dates. Hearing, I would suggest, is likely to be next year. Anyone who's made a submission will have their submission considered by that panel. You don't need to appear, but if you wanted to appear before the panel, you're invited to do so. Following on from that, the panel will make a report recommendation to council that gets reported back to council laws for a decision, and ultimately the final form of the amendment, if adopted by council, will then be sent to the Minister for Planning for final approval before it becomes legal in the planning scheme. So we're probably a good six, maybe 8 months off getting to that final point, and the Minister does have discretion to take as long as they would like to approve the planning scheme amendment. However, I would suggest they would do so fairly quickly in this case. So just want to thank everyone for listening in and asking questions. That's been very helpful. We do have some FAQs on our website, but we'll also be mindful of the questions asked tonight and may include some of those on our website as well. Once again, thank you for your time, and we'll make this recording available on our webpage in the next few days. So if you know of anyone else who wasn't able to attend tonight, they'll be able to do that. We do still have some other sessions coming up in the next few weeks as well, and they can be registered via our Shaping Yarra Ranges EMO webpage. Thank you very much to the panellists and also my staff behind the scenes, and I hope everyone has a good night. Thank you.
Thank you, everybody.